Zener diode characteristics or heavily doped diode characteristics or voltage regulator characteristics. The other name for Zener diode is voltage regulator. The Zener diode is a heavily doped diode. Now to draw the characteristics of Zener diode, this is Zener diode VI characteristics. Now from the observation of the table, graph forward voltage. Now here forward voltage we will call it as VZF. For a normal diode we will call it as VF. Here we will call it as VZF. Zener diode forward voltage. Now the voltage maximum value is 0.7 volts from the table. You can consider 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 and 0.8. Corresponding the values of current. The maximum value of current is 1.7. You can observe if you take 0.5, the maximum value will be up to here only. You can consider as 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. Here current is in milliamperes. Current IZF, Zener diode forward current is IZF, which is in milliamperes. Now to plot the graph, if you observe the table at 0.1 and at 0.2 the value of current is 0, and at 0.5 the value of current is 0, at 0.6 the value of current is 0. Now it varies from at 0.6 only the value of current is 0.1. This is the corresponding point. At 0.6 the value of current is 0.2. At 0.7 the value of current is 0.3, and the value of current at 0.7 only 7 volts only 0.3, and next is 0.3, again 0.5, 0.7 volts only 0.6, at 0.7 only 0.7, and at 0.7 only 1.7. Now if you draw these all points with free hand by neglecting one or two points, this is a Zener diode forward bias characteristics. This voltage is called cut-in voltage for the Zener diode. Now here you only need to write down the scale. X-axis we have considered is 1 unit is 0.1 volt, y-axis 1 unit is 0.2 milliamperes. This is a Zener diode forward bias characteristics. Coming to reverse bias characteristics, by observing the table we can find out corresponding to 0, the value of current is 0, and the maximum value of voltage we have applied, RPS voltage is up to 10 volts we are applied, but the Zener voltage maximum is 4.5 only. Now we are considering 0, 0.5, minus 0.5, minus 1, minus 1.5, minus 2, minus 2.5, minus 3, minus 3.5, minus 4, minus 4.5. Minus 4.5 is the maximum, that is the reverse voltage we are applied. Corresponding to the current maximum value is 6 minus 6.8. So you can take it as minus 0.5, minus 1, minus 1.5, minus 2, corresponding to the each block, minus 2.5, minus 3, minus 3.5, minus 4, now in the reverse bias, if you place the points up to 4 volts, 3.9 volts, this is 3.9 volts is a diode, Zener diode, for 3.9, 3.9 corresponding to 3.9, the value of current is 0.4. At 3.9, this is a 3.9, this is a point, this is 0 minus 0.4, this is the value of point. Now at minus 4.3, the value is 1.4, minus 4.3, this is minus 4.3, 1.4 is the minus 4, at minus 4.4, 1.3, this is a 1, this is 1.2, this is 1.3, this is at, this is a point, this is at minus 4.4 to 1.4.3 to 1.4, this is a corresponding point, minus 4.3 to minus 4.3, this is 4.25, corresponding, this is a point, minus 4.4, it is minus 2.2, this is a point, 2.2, this is a point, at minus 4.5, it is of 4.2 is the value, this is 4.2, this is a point, at minus 4 point only 5.4, and this is a 5.4 means this is a point, at minus 4.5 only 6.8, minus 6.8, this is a point. Now if you connect these all the points, (3.20). Now if you connect all these points, you can obtain, this is the graph. This voltage, this 4.5 volts is called reverse breakdown voltage of the Zener diode. Reverse breakdown voltage of the Zener diode. This is a, now coming to the scale of the graph. Now here x-axis is 1 unit is 0.5 volts. Here is volts only. This is VZR. This is also in volts. VZF is also in volts. Y-axis 1 unit is 0.5 milliamperes. In Zener diode reverse bias characteristics and as well as in forward bias characteristics, the current is in milliamperes only. This is the graph of the Zener diode in forward bias condition. This is in reverse bias condition. Coming to the calculation of resistance of diode, Zener diode can be obtained by using the formula V by I, that is VZF by IZF, by considering 0.7 volts. The corresponding current is 0.5 milliamperes, which is, you can find the value which is equals to 1.4 kilo ohms. Coming to dynamic forward resistance RAC, delta VZF by delta IZF. Dynamic resistance delta VZF by delta IZF. change in voltage is 0.7 minus 0.6. Corresponding the values of current are 1.7 minus 0.1, and the value of dynamic forward resistance is 62.5 ohms, which is obtained here. Coming to static reverse resistance from the reverse bias characteristics and the table VZR by IZR. Corresponding to 4.5 volts, we can find out the value of current is 4.2 milliamperes, which you can obtain 1.07 kilo ohms is the static reverse resistance. Coming to dynamic reverse resistance, the value is delta VZF by delta IZF, delta VZR by delta VZR by delta IZR. Then you can find out the values, which is 31.25 ohms. This is a calculations of the from graph or table. Thank you for watching. Please like, share and subscribe if you like.